this is a question with our planes and lines, but one that doesn't seem to come up very often, so you might not have seen the example of before. So we've got our plane, and then we've got our line 1, and it says line 2 is a reflection in the plane. Okay, and we've got to find the vector equation of line 2. So, well, what do we know about line 2? For a start, wherever the line 1 intersects the plane, that point's also going to be on line 2. So let's see if we can find that point. So to do that, I'm going to use the formula book, or just your knowledge, to rewrite this Cartesian equation into vector form. So that's going to be 2, 4, negative 6, so the point being the numbers we're adding or subtracting, plus lambda times, and the direction is the numbers you divide by. I'm then going to turn the plane into normal form, so r dot n equals 6. So remember r is x, y, z, and so that, if you did multiply it out, would be equivalent to our Cartesian form. Right, I want to find where those two intersect, so you can write my coordinates of any point on the line and substitute that into the plane. And then just multiply all that, work out the dot product. And then if you rearrange and solve that, you should get that lambda is 2. So when lambda is 2, I can now substitute that into my line equation. So a point on line 2 is 10. Whoop, let's tidy that up a bit. 10, 0, negative 4. So now we know a point. Right, what we want to do is now find out something else about line 2. So what can we do for this? Well, what we can do, if we have any point on the plane and a point on the line, well, we know a point on the line. If I call that A, the point on the line is 2, 4, negative 6. That's in its equation that we got from this one. And so what we could do is we could find the equation of a line that goes through the plane and is at 90 degrees to the plane, and goes through point A on line 1, and then we could use that to find out the image of A on line 2 after it's been reflected. Right, so what can we do with this? So we want the line which is perpendicular to the plane and through what I've called point A there. So that's going to be our next line, so that's r 2, 4, negative 6 point plus scalar times direction. So we want the normal vector for the plane there. Okay, and that's the blue line. Right, now all we want to do is find out this vector from A to P, for example. So we want to find out where P is so that we can work out the vector A to P. So if a point on both plane and line, we're using the same technique we just used. So we're on a point on the plane and the line, so we're going to take this and substitute it into the plane. Okay, and if you solve that one, you'll get that mu equals 3. So when mu is 3, we want to know what's the point on the line, and that's my point P. So O to P is 2 plus 3, 4, take away 6, and oops, and negative 6 plus 3. Okay, so now I know where P is. Okay, now what I want to do is I want to find the image of A. So to get to the image of A, what I can do is I can go from A to P and then down the same distance to its image there. So I want to get to my what I've called A dash, the image of A. So that is go to point A and add off 2 dots of the vector A to P. So point A was 2, 4, negative 6. 2 dots, and then I want the vector from A to P. So the vector from A to P is OP minus OA. Remember, second take first. So that's P, and then subtract coordinates of A. And if you work all of that out, you should get to 8, negative 8, 0. So that's now the coordinates of this point here, not A dashed. I think my diagrams are coming quite littered now. So what I was trying to do was find the equation of line 2. So I just made that a bit smaller so we've got a bit more room. So we want line 2. So that's going to be R equals, so we want a point on the line. So a point on the line is our either our image of A or our point of intersection, it doesn't matter. Okay, plus some sort of scalar times the direction. Again, there's going to be multiple options, so the direction is going to be the vector between the image of A and that point of intersection. So to get our direction vector, we're going to, for example, do 8, negative 8, 0, subtract 10, 0, negative 4, for example. So that would give us 82, negative 8, 4. Obviously you would simplify that in that. You could also subtract those the other way round. So you could have 2, 8, negative 4. You will notice also that they're all divisible by 2. So you could have, if I simplify this one, negative 1, negative 4, 2, or basically any scalar multiple.